The analysis of variance table is really no different from what we looked at in Chapter 10. The only thing that's really going to change are the degrees of freedom right here. In Chapter 10, regression analysis, this is always a 1. It's going to be different for analysis of variance. And so I'm using the numbers from the textbook applied to the crime rates by region of the country, by state, by region of the country. And my source is the region of the country. And that's the independent variable. The sum of squares, the author tells us, is a big number, 662,641. And then the residual sum of squares is 2,141,613. And if you add those together, you'll get the total sum of squares, which is 2,804,254. So again, if you have just two of those, you can figure out the third one, because the top two add up to the third. Now then, so this was the independent sum of squares number. This number is the residual sum of squares number, and here is the total sum of squares number. So that's ties it into that terminology. Okay, well, from here we can do all the other calculations. So the heaviest work is done by getting these numbers right there. That's really is a lot of tedious work to add all that stuff up. Now then, the proportion is the proportion for the independent variable, or the categorical variable, is if we take this sum of squares and divide by the total. So I'll take 662,641 divided by 2,804,254. So 662,641 divided by 2,804,254 is 0.236 or 0.24. And our book this time goes to two places, 0.24. And then if we take the residual sum of squares divided by the total, this number divided by that number should be the complement. Should be 0.76, because these two will add up to 1 every time. And so that's what they got. Now, this number right here, 0.24, is the r squared number. So we'll talk about that a little more in a few minutes here. But let me write that down. R squared, capital R squared, is 0.24. So let's hold that thought for a moment, and I'll fill in the degrees of freedom here. Now, we had 7 regions of the country. The degrees of freedom will always be 1 less than the number of groups or categories. Okay, so there's 7 categories, 7 groups, and the degrees of freedom for the region of the country will be 6. It's going to be 1 less than that. All right, again, that's buried in the details of coming up with these tables and using them, mathematical theorems that decide all that. And so we're going to declare this to be 6. The total degrees of freedom is going to be sample size minus 1. So that should be 47. Because N was 48. There were 48 states. We left out Hawaii and Alaska, didn't count those. With 48 states, N minus 1 would be 47. So that's the total degrees of freedom is always N minus 1. So 1 less than the number of categories, 1 less than the sample size. As far as residual squares of freedom, that's going to be the difference between these two numbers, which would be 41. All right, so this probably has to puzzle you a lot. Again, these really, everything right here gets you to the p-value. All right, there's nothing too cosmic about degrees of freedom. It's just a device, along with mean squares and F ratios, that eventually allows us to get the p-value, which is what we're really looking for here. So the mean square, we're going to take this number, the independent study, the ISS, independent sum of squares number, and divide by its degrees of freedom. So 662,641 divided by 6, according to our book, is 110,440. So let me just double check that. I'm sure that's right on the nose. But sometimes the book is off by like a rounding error. Yep, 110,440. And now for this mean square, for the residual, we'll take its residual sum of squares and divide by its degrees of freedom. So 2,141,613 divided by 41 degrees of freedom is 52,234. 52,234. There we go. So those are called the mean squares. And again, it's just a device that will eventually lead us to the p-value. Now the F ratio, this number, you get by taking the top mean squared divided by the bottom mean squared. And so we'll take 110,440 divided by 52,234. So 110,440 divided by 52,234 is 2.11. So that's the F ratio for this data. There we go. Now then, the author gives us a p-value, which you use software to get that. And but I'm going to approach it naively as if we don't have the book, this book answer in front of us. I'm going to go to the F ratio table in the back, and our denominator degrees of freedom will be 41. So I need to page over, see if I can find 41. And of course we don't, we find 40. So if you look on page 662, the denominator degrees of freedom go down the left side. And on this page it goes 29, then 30, 35, 40, 50, 67, 80. The closest number to 41 is 40. So let's pick the 40, which is right about in the middle. And then the numerator degrees of freedom are 6. So this time we go across the page under 6. So under 6 down to where 40 is, I have these numbers. 1.93 is the first number there. So here are the numbers that I have that are relevant to this problem. 1.93, then 2.34, 2.74, 329 and 473, 3.29 and 4.73. There we go. Now then, our p-value was 2.11. So it fits in between there. And what are the probabilities? The probabilities are 0.100, 0.050, 0.25, 0.01, oops, 0.10, sorry. And then 0.01. So there are the probabilities. And this is the F ratio number. And that means our probability value, our p-value, is going to be here. It's going to be larger than 0.050 or 0.05. It's larger than 5%, but less than 10%. So because we would reject the null hypothesis normally for above 0.05, I'm going to declare that the p-value is greater than 0.05. And the textbook, using software, actually got 0.072. So that's consistent right there. So anyway, what do we do? Well, there's only one number here that makes a difference. Now, normally there would be two. If we have a small p-value and we reject the null hypothesis, then we're also going to be interested in r squared and r. But in this case, we failed to reject the null hypothesis. Well, what in the world was that? The null hypothesis is that there's no differences among the categories, among the groups. In this case, more specifically, there's no difference, statistically significant difference in the crime rates by region of the country. There's not enough evidence to conclude that there's a significant difference in those regions of the country. Because the p-value was greater than 0.05, and so that's it. Let me write that out in kind of plain English. It's kind of hard to do this with symbols. The null hypothesis for this particular problem is that there is no difference in crime rates among the regions. No difference in crime rates among the regions. And and maybe difference may not be the best word here. Maybe I should say relationship. Well, I'll tell you what, no, let me keep no difference here. I'm going to just, probably another way to state this is that there's no relationship between the region of the country and the violent crime rates. No relationship between those two. The alternative is that there is a relationship between regions and crime rates. Alright, so we failed to reject the null hypothesis, so we don't have enough evidence to conclude that this is strong enough to show that there's a difference in crime rates by region of the country. So anyway, with a p-value of greater than 5%. Alright, well, so there's kind of the gist of analysis of variance. We haven't really talked much yet about capital R, though, and we'll talk more about it as we get into problems. But in this case, there was not enough evidence to show that R was anything other than 0. In other words, capital R equals 0 means no relationship. And so we didn't reject that possibility with this data. Okay, well, let's go on and work some book problems and talk more about all this.